Yes. Yes. Okay, and remember that the next Tech Talk is tonight, 6 p.m. in the Collaboratorium. And that's with Aurora WDC.
Same place.
Yeah. Yeah, that's with Aurora WDC. And they're, I think they have 4 of our alum working there full time. And then including our student of the year from 2 years ago. He works there. And then we have, I think, 4 or 5 interns that currently work there. And 3 of them started while they were in the 250 class. So the next, yeah, coding 2. They started there the summer right after that. So you guys are right on the cusp of being able to go and do like real stuff. And they're working with things on blockchain technology. So like the things that like involving Bitcoin and Ethereum and that stuff, the underlying technology is called blockchain. They're also doing some quantum computing stuff with me. That's pretty cool stuff. We might even do some quantum stuff in here when we do deal with objects. All right. All right, so before we solve the homework assignment, let's talk about a midterm. So next week is a short week, right? So fall break is Thursday and Friday next week. So all classes that meet after I think 4 p.m. Wednesday are so you will meet for your classes on Wednesday up until 4 p.m. After 4 p.m., that's when break officially starts next Wednesday. So really we'll only have 1 class next week, and we're going to be at a decent breaking point. So we'll go ahead and do the midterm next week on Tuesday. Midterm, all my exams, you can actually just assume this is every exam you'll ever have with me in school here. There will be 10 questions, all short answer essay programming, so no true false, multiple choice, none of that stuff. Each question's worth 10 points, so they're all equally weighted. A couple things that'll definitely be on the exam, and then I'll flip through the slides and kind of point out the areas that I think would be places to focus on. There will at least 1 conversion question. This is convert between 2 bases or convert between sizes like megabits and gigabytes, that kind of stuff. All right, so be able to do that. That should be free 10 points. Typically on the first exam, there will also be a question, rate in error-free Hello World program. All right, remember I mentioned that kind of a good starting point for any language is to kind of inside your head get just that starting template for any program in that language. You'll find most languages are pretty similar, but you should be able to write the include IO stream using namespace, it main, see out hello world, get the curly braces in there, no errors, all that jazz. Good. Yeah, you'll have to know it. Yeah, until you won't be running any of the programs on there. I want you to do it out of your head. But I'll grade it with that in mind. So if you like miss a semicolon, I'm not going to knock you for, you know, a zillion points, because a quick error message would have shown you you missed the semicolon. But I do want to see, typically when I'm grading exams, I'm looking at competency. It's pretty clear when you're looking at a programming answer whether the person pretty much knows what's going on or they pretty clearly don't have a clue what's going on. Be prepared for the first exam. This should be hopefully the initial wake-up call for you if you're not getting what you should be getting out of the homework, or you're not spending enough time on it or whatever. Remember, I kind of talked about computer programming being like a sport. So you need to be putting the reps in. And if you're not putting the reps in, you're not, I mean, realistically, I kind of warned you the first week, if you're not spending on some of these assignments multiple hours on them, you're probably not putting the reps in. If you've had some programming before and you can sit down and write these assignments in 10 minutes, that's fine. You'll probably be just fine on the exam. But for those of you where this is the first time you've ever seen coding and things like that, the reps need to be put in. You need to spend the time, and you have to grapple with the mistakes and debugging and all that stuff. It's just part of what it takes to become a good programmer. So some of you are probably going to not do very well on the programming questions on the exam. Remember, I have the policy, if you do better on the final exam than you do in the midterm, I'll replace whatever you get in the midterm with what you get on the final exam. So that all being said, for some of you, this might be a wake-up call that, oh, I'm not really getting what I need to get out of the homework assignments, because turning in a correct answer for the homework assignment isn't really going to get you anywhere in here, because the exams are worth enough points that it can supersede that. So if you have a couple of friends you work with and you're just submitting the program that they wrote and you didn't really learn anything from it, I'll find out in the exam. I don't really care about get your full credit on the homework assignment. You know, the exams are going to bring your grade down, because typically, like I said, since my exams are not true, false, multiple choice, the chances of accidentally getting a decent grade on it are pretty low. Okay, so I'm looking for competency. Now, having said that, typically my exams are polarizing, where half the class gets 85 or better, and then the other half of the, well, maybe there's a middle group that gets like in the 50s or 60s, and then there's like the 10s, where they basically couldn't fill out the exam because they don't know what's going on. So then you have to ask yourself, is this not my cup of tea, or have I not really been spending the time on the programming stuff that I should be? Okay. So really what I just showed you on the screen here is a minimum of 20 points, maybe even 30 points of the exam, being able to do 1 or 2 conversion questions and write an error-free hello program. So I've shown you a third of the exam already almost. So if you miss those, then I don't know what I'm supposed to do with that. All right. Was another question? Let me flip through the slides that we've gone through so far, and I'll point out the things that I think would be worth spending extra time on versus things that might be interesting, but I'm probably not going to test you on it. You also need to consider, when you study for exams, and this really goes for any class, ask yourself, for this concept, if would a teacher test me on this? Ask yourself, what kind of question could they ask? Because sometimes the issue we run into as teachers is, we might have a concept that we really think you should know, but there's no good way of writing a question around that. So that's when we wrap it into a homework assignment or something. Go ahead. Yeah, but I would say in general, the programs on the exam will be not as complex. That doesn't mean they won't still feel complex, because I mean, you've seen me come to class and we typically are solving the assignments in just a couple of minutes. But that's going to be a pretty big gap between your experience doing the homework for many of you and then what it looks like when we come to class, because you may have thrown significant hours at something that, yeah, only took 5 minutes to write. But those significant hours dealt with a lot of trials and tribulations, and that's where the learning actually took place. So it would probably be less complex things. I'd probably say, like, write the code necessary to do this, or create a function named whatever that returns this kind of value and manipulates a string or something like that. Either prints a string in reverse, or builds up a new string that only has the vowels in it or something like that and returns. So really drilling that idea of remembering stuff, asking questions, repetition. All right. And realistically, probably half the exam will be probably programming of some kind. There might just be one-liners or something, like write 1 or 2 lines of code that accomplish something, that kind of thing. So maybe like a question like define a variable capable of holding a string and then display the length of that string generically, or something like that, wanting you to call the length method. Potentially, just that's like an example. Yeah. And like a question where I ask you to write a function to do something might be take a string as a parameter and return that string in reverse, for example. So more than likely, I'm going to be testing you on that concept of, do you know what it means to return a value versus display a value? That is void functions versus functions that have a return type. So make sure you're reading the question clearly, because I will point out whether I expect you to return something or display something, and you should know what that translates into in terms of writing the method header and then the logic inside there. All right. You're not going to get partial credit on a programming assignment or programming question if you just like write the word int and it just happened to be part of the 8 lines of code you were supposed to write. Like, whoa, I wrote something that involved it. Whoa. That'll come back on. It'll, yeah, it was a kidney shot. Yeah, it was. Yeah, so don't expect partial credit for trivial things like that. Again, I'm measuring on competency. If you write something that pretty much is right, you showed me that you know what's going on, and I believe that if you ran that through a compiler within a couple of minutes, you'd have it kind of patched up, I'll probably give you full credit. Okay. But on the other extreme, you're not giving me much, I'm not giving you probably anything. So that's the deal. So notice here, your exams are 40% of your grade. But I do replace your midterm exam grade with your final exam grade if you do better in it. So hopefully for some of you, this will just be a wake-up call. All right. Very possibly this slide, kind of the basis for how I teach programming is around this. So how do human beings solve problems? Memory, asking questions, repetition. Maybe ask you something like that, or ask you, how does C++ represent these things, through variables, conditionals, if statements, and like loops or functions. That's this mapping slide. So that's certainly fair game. Certainly fair game. Yeah, I'm not promising you what I'm going to ask, but when I sit down to write the exam, I'm going to do the exact same thing I'm doing right now. Flip from slide to slide and decide, is this important? And then I might end up writing like 13 or 14 questions, and then I'll pick my favorite 10. Nothing about HTML. It would be fair for me to give you like around the idea of algorithms, kind of like creating a recipe for your program. Maybe ask you a question kind of in the middle where I might say, give me step-by-step instructions for making a peanut butter and jelly, something like that, asking you to break a common problem down into the distinct enough steps that you could turn that into a computer program. So kind of practicing as a human being, explaining to another human being in a pretty granular way the steps of making a peanut butter and jelly, for example. Well, and the thing is, you don't need to go to the extreme, but I would ask that you do break it down into, like something more than grab peanut butter, grab jelly, make sandwich. You'd want to expound on what making sandwich means, but you don't necessarily need to tell me about how you're articulating your thumb to pick up the jar of peanut butter or something. But there could be a question along the lines of, it's not a coding question, but it's showing me that you're practicing breaking problems down into those kind of more granular pieces. Certainly a question between high level, low level, and machine level. I like that type thing, along with compilers. Like, what's the job of a compiler? Converts a high level language into a low level language. All right, so understand that machine level is the zeros and ones, low level is a one-to-one relationship with the CPU, and high level is a one-to-many relationship with the CPU. We write one line of code, and after it's compiled, it translates into a whole bunch of things that the CPU needs to work with. Compiled versus interpreted. Let's say yes. I would probably lean more towards the compiled side of that for this exam, since we're using a compiled language in C++. Go ahead. That's an interesting question. I originally was leaning towards in person, but that means we have a lot of paper. So we might do it during class time on Blackboard. So you won't be able to just do it whenever you want, but it might be during class time on Blackboard. If you want to come here and sit and do it, or do it in your dorm room or something like that, that's fine. And I'll make sure I'll probably jump onto Zoom and just be available if you have questions during it or something. But I'm probably leaning towards that. Yeah. And again, I'm not going to like knock points for you use the capital or S on string instead of a lowercase s. Those are things that pretty quickly the compiler will scream at you and you'll fix. Okay. It's going to be very clear to me whether or not you mostly know what's going on and you mostly don't. Go ahead. Converts a high-level language into a low-level language. So I would say very important that you understand the difference between these three: high level, low level, machine level, and then understand the role of a compiler. That compiler is that glue for us, right? We write the stuff in C++, a high level language. We compile it, and it does all the magic of giving the zillions of instructions ready for the CPU to digest. That in mind, also the nature of the CPU. CPU kind of has a collection of magic tricks on it, has a whole bunch of little things it knows how to do. That's what those low-level instructions are. Remember, we looked at, I think, Hello World and Linux assembly in here. I wouldn't show you like that and tell me, step by step, what does this do? But I want you to understand that was low-level code that we looked at. Yeah. So these three: compiled, loosely typed versus strongly typed. C++ is a strongly typed language, so maybe know what that means. Strongly typed languages require you to define the kind of value that a variable is going to hold when you first define it, where a loosely typed language does not. C++ is a strongly typed language. Probably nothing about general purpose versus domain specific. All of the languages you're going to be dealing with are going to be general purpose languages. Every now and then, if you're going to be a programmer who's writing software for a dishwasher or something like that, that would be probably a general or a domain specific version of a general purpose language that only has functions for dishwasher function thingies. Rinse cycle, soap cycle, whatever it is. But I would say this line here is not an overly important concept. I probably wouldn't test on that, and definitely not this guy down here yet. But this is going to be a very important concept for the second 8 weeks when we start talking about object-orientedness. All right. You should know what the job of a programming language is. I don't know if I'll ask a question on it, because that might be a hard thing to ask in an interesting way, but at the very least, you should know what you're doing when you're programming. You're telling this guy what to do. The concept of main, all programs begin and end with main. I could ask a question around that. Like, why is this a true statement? I'd be looking for something along the lines of, the history of the programming languages back to C, require a main method. We still see that. And when you run the program, the first thing the program does is it goes to main and starts at line 1. That's a consistent thing across programming languages. I could also ask a question around why does main return an int in C++? I would say that's a lower probability, but if I needed an extra question, I might say something like that, where our older programs used to return a value to tell us whether it worked or not, or give us an error code, where today we're launching stuff as more of a GUI. So definitely know this stuff. That's one of those conversion question thingies. So be able to go from bits to gigabytes, all that stuff. So know that everything on the left-hand side here, the lowercase b, is defined in terms of bits. And these go up by 1024. Then we jump by a scalar of 8 to get over here. And these are big B's are bytes. Bytes are a collection of 8 bits. So be able to do those conversion questions. I will probably have one each of a question converting this and a question converting some base. Maybe even have a third one. Yeah, so, something like that. Probably nothing on this, because like I said, this is going to be the focus of the second 8 weeks, this idea of taking our procedural approach we're using right now and moving to an object-oriented approach. Converting between bases stuff. Know our 2 patterns. I might ask a question about each of those patterns. The pattern that goes from decimal to any base versus base to any base to decimal. Those 2 separate approaches you have to use. You might want to familiarize yourself with those the tricks for going from binary to octal, binary to hexadecimal, using 3 and 4 bits to represent it. I won't require you to use the trick, but I might ask a question, that one of the conversion questions. I might say, convert this number from octal to binary, something like that. And if you know the trick, it won't take you very long to do it. Otherwise, you're probably going to end up writing the answer by converting octal to decimal and then decimal to binary. You'll end up with the same answer, and that's not going to be a problem. So I'm not going to take off for it, but I may ask a question that would allow you to take advantage of one of the shortcuts. And here's that example where for octals, all of the octets can be represented as 3-bit values there. So 127 in octal, this is the 3-bit version of 1, 3-bit version of 2, 3-bit version of 7. This is 127 in binary. That's shortcut. And you do the exact same thing with hex. Hex, you use 4 bits to get you 0 through 9. Well, 0 to 15, 0 through 9, A through F. Definitely be able to use the modulus operator to get the remainder of integer division. There'll probably be a question on there about integer division. Like 9 divided by 2 is 4 with a remainder of 1. So 9 mod 2 is 1. Well, it's because I had them pre-made and then I just wrote them again anyways in the order that I hit them. So probably making a slide set, starting with the slide set and then adding to it probably wasn't all that smart, but at least we review stuff multiple times. Definitely know what the primitive types are, because you should be capable of defining variables with correct types, writing functions that return the correct type. I won't ask you questions like, what's the range of values that fit inside of a short? Don't do that. Although, I mean, it's if you remember, a short is a 16-bit number, then negative plus or minus 2 to the 15th is not hard to remember. Definitely know the concept of a function that returns void, so it returns nothing. Definitely know the purpose of the return statement. Return statement makes a function immediately end, and then optionally can return a value. So if you're inside of a void function and you want the function to die, you can say return followed by a semicolon. Don't put a value you're going to return because that function wasn't advertised as returning a value. But you can kill off a function at any point in time if you're done. You know, you found something that disqualifies the rest of the function from doing more stuff. You can just say return, and that function will die. It won't loop through again or anything. All right, but you should know about all these guys. I would say there's a possibility if I needed an extra question, I might ask that question of why do we have so many ways of holding signed whole integers like bytes, short, ints, and longs? Why do we have so many different ways of holding the same kind of values? And that deals with that whole, we used to not have very much memory, so we used to have to pick the right integer type to hold the value that we needed to store, but don't put, if you only need to store the numbers 0 through 5, don't define an int, which can hold -2 billion to +2 billion. Use a byte, which can hold -128 to +127. But modern programmers, since we have plenty of memory, we pretty much use an int unless int isn't big enough, and then we use a long, like in that problem you were talking about. Low probability of that question, but possible. Just to make sure you understand why we have all these different types built into a language like C and C++, which are older languages. And those have even followed through to our modern languages. We still have these types in Java and C#. But you'll rarely see shorts in the wild anymore. You'll occasionally see a byte, but for a different reason. That's like more video streaming type stuff where things are coming in 1 byte at a time. It just happens to be the right size little container to hold the data in the form it's coming in, not because you only need to hold a number between -128 and +127. And I wouldn't ask you that question about bytes specifically. Could ask a question about the char primitive type. Maybe I would ask, why are chars unsigned whole integers? Right? It's because it maps to in C++, the ASCII character set. In more modern languages, it maps to the Unicode character set. So Java, C#, a char is actually a 16-bit unsigned integer because it can store 65,536 unique values. And that lookup table that has, here's, 0 is this letter or this character, 1 is this character, 2 is this character, so on and so forth. The first 256 of which are the same. Unicode is a superset of ASCII. So the first 256 characters in Unicode match the first 256 characters of ASCII, or match the ASCII character set. And that's actually extended ASCII, because original ASCII was only 128 characters. But Unicode is everything that ASCII ever was, and then more for symbols of other languages and stuff. I wouldn't ask you to go into that level of depth, but you should probably know the concept of ASCII. You don't have to know what it stands for. American Standard Code for Information Interchange is what it stands for, but that part doesn't really matter. The concept of ASCII is we have a table that lets us map from a number to a character, because computers like numbers. That's why the char type is a unsigned integer, because we're going to still store the number inside the computer. And then when we go to read it and display it, because its type was char, we'll do that mapping behind the scenes. The computer does that mapping and looks up that number on the ASCII character set. All right, so I would say that is a pretty important concept that you understand why chars are numbers. Definitely Boolean expressions. I might not ask the trivial question of what's a Boolean expression, but I do like that question. You notice I ask it often in class, but you should be very comfortable writing Boolean expressions, because you're going to have to use them inside your if statements, inside of your loops. And I promise you, some of the coding questions will involve if statements and loops. All right. So not only know what a Boolean expression is, that's any expression that boils down to a single value of true or false, also be able to write them using the logical and arithmetic Boolean operators. So be able to say, is some variable less than some other variable, or if this is true and this is true, do something. Be able to formulate Boolean expressions. So there's your arithmetic operators. There's your logical operators. Know the syntax for if statements. So I promise you, probably all the programming questions, or a high percentage of them, will ask you to have some code, and there will likely be an if statement in there. Know the syntax of the if statement. Here's that integer division stuff. So this is where we talk about integer division versus the remainder. So know how to use those things and be able to use it maybe in a problem. Like the homework for today, you used modulus, right? You modded by 26 to make sure it did the automatic wraparound thing. And we'll look at that. Nothing on bitwise operators. That was more of that trivia thing, so that if you accidentally ever do put just a single and you get a weird numeric answer, we explained why you get that by performing the ands or or operators on individual bits. That's something that's more important in computer architecture, not in programming. I introduce it more of a beware if you get a spooky behavior without an error message. Because those are the worst errors, when your code runs, but it doesn't give you the answer you want. That's why you always want to, for those of you who've asked me questions when you're working on your homework, the first thing I'll say is make sure you give yourself an example and walk through it by hand and ask yourself, what is the program doing to my values each time through? And eventually you'll stumble upon the mistake. You'll say, oh, I expected to get a 4 out of this, but I actually got a -1. Why? Maybe it was an uppercase letter you were passing in, whatever it is. But just because you think you wrote code that does one thing, convince yourself of that by walking through it by hand, and usually the bug you have will reveal itself when your compiler doesn't give you an error because you technically wrote legal code. It just isn't code that does what you were trying to do. Those are the worst bugs. Definitely be able to use loops. For loops and while loops, we haven't used the do while loop in here at all, but for loops and while loops will cover you 105% of the time. All right, but know the syntax of those things, and in context be able to understand the concept of variable scope. That's kind of an example of one of those things where it's a really important concept, but sort of maybe difficult to ask a question around it. But if I were to ask a question about scope, that might fall into the category of, sometimes I'll give you questions where I show you some code and I say, what does this code do? And I'm not asking you to walk through it line by line, telling me what each individual line does. You can do that, but ultimately what I want you to tell me is, as a whole, what does this code accomplish? This code converts a decimal value into a binary value, for example, or this code prints out all the odd numbers between 1 and 1,000,000, whatever. I'm looking for that, because for many of you, you currently can read code when you see it written significantly better than you can write it yourself. Orders of magnitude, right? Most of you are going to be in that point right now where it's like, okay, when he shows me the solution, it makes sense, but I don't know where to start. Or I hit a wall 3 lines in and I don't know what's going on. You get intimidated. You don't know what to do. That's normal. That's where you I wouldn't say should be at right now, because that's where those reps come in, where you should be spending a lot of time on your assignments. But don't just throw useless hours at it when you hit a wall and you've banged on it for a little bit. Then come and get a little help to get you past that hurdle, which then will hopefully get you back to the races for another hour until you hit the next hurdle. That's that learning process, but that's pretty normal for you to be able to read someone else's code significantly before you could write it yourself, which is frustrating, right? It's like, this makes sense to me, but why can't I do it? Part of it is you'll learn what kind of errors you're prone to make, and part of it's confidence. Part of it is skipping steps, like trying to solve stuff in your head first instead of writing it down, drawing your pictures and stuff. Eventually, you won't have to draw pictures until you get to the more complex problems, let's say, but don't take shortcuts. Again, I promise you, master this skill, and then you go retire early. It'll pay you very well. It's worth the efforts at this point. All right, but definitely be able to use loops, for loops, while loops interchangeably. I probably would not ask a question where I say, you must solve this with a while loop. I would ask you to choose the loop that you want. Most questions I might ask are probably going to be numeric type problems, like maybe loop through this string and count the number of spaces or something like that. So I'd ask that you be able to create the loop that goes through every bucket of a string. We typically have done that with a for loop, but if you want to use a while loop to accomplish it, that's fine. It's not wrong. Okay, understand variable scope, that idea of where we have access to a variable, and kind of that idea why we can have two for loops immediately following each other, and we can use the variable I 2 different times because I died. It was born and died with the first for loop, which then allows us to create a brand new one in the next one because that scope ended. I won't ask you a question about variable resolution, but when I'm asking you to read code, I mean, you should sit there and say, well, what's the current value of the variable B? Something like that. That's resolving that value. Go ahead.
So first of all, yes.
No, but if I had like for int I equals 0, I is less than 10, I plus plus, and did some stuff, and then immediately following that loop, I had another for loop that said for int I equals 10, I is greater than equal to 0, I minus minus. I'm allowed to define that variable I another time because it's the original one died. Its scope was born inside the first for loop and died at the end of that for loop. So there is no longer, if you remember when we went through this, we originally wrote a for loop, that the for int I thing. And right after the for loop, we tried to print out the value of I, and it yelled at us and said, I've never heard of it. It's because I died when that for loop ended. It belonged to the scope that for loop created, that opening and closing curly brace of the for loop. That created a new local scope. And the I that we created, because it was part of the syntax of the for loop, it only existed as long as that for loop was still running. And as soon as we passed the for loop, it's as if C++ never heard of a variable named I, which made it free for us to go and use it again, whether it's in another for loop or just use it as a generic variable, whatever we want to do. Okay, you said you had a second question? Okay, so I'm covered. Okay. Yeah, but be able to do variable resolution. Again, this comes with practice reading code. Ask yourself, and one of the things I try to do in class is I try to mimic what I kind of expect you to do when you're going through stuff, even though for a lot of these things, I don't need to do that, but I've been doing this for a couple of minutes. But I might say, what's the current value of I? I is currently 5. We're going to now set I equal to its current value, 5 plus 1. So now I is 6. You kind of almost like beating a dead horse. You're just going through, is like, okay, that seems trivial. Until you really, really, really get bored with doing that yourself, force yourself to do it. Kind of speak out loud what your code is doing. And eventually you just won't have to do it anymore because you'll see that, oh, I understand this stuff. Nothing on that yet. Definitely strings. I would say there will be at least one, maybe even probably 2 programming questions dealing with strings. I happen to like questions on exams that deal with like manipulations of collections. So like I said, maybe build a string in reverse, print a string in reverse, write a function that takes a string in and returns a new string that is the original string with all the spaces removed, something like that. So I like manipulating strings, forcing you to do string concatenation type stuff. So like when I say something like remove the spaces, what do? Instead of removing spaces, we go through and we keep everything that's not a space, concatenating it up, and then I return that value, something like that. Go ahead. Well, the common ones. So like, for instance, I would expect that you would know like the length method of a string. But not necessarily, for example, some of the things we had to do in here when we were concatenating, we had to first convert an int to a char to make it, or into a string. If you solved the whole rest of the problem correctly, you just didn't convert the type, you did it right. You know, it's pretty clear to me you knew what was going on. C++ would scream at you, you'd fix it because it would say, hey, the plus operator is not defined for a string and an int. No problem. I'm not going to take off points because you showed me what was going on. But I would probably not try. I don't try to trick you on exams, so I'm probably not going to give you something real crazy that we talked about for 5 seconds at some point in time, and it's some trick. I want to see, can you just write kind of normal programs, given you're going to have a time constraint of an hour and 20 minutes or whatever it is. And in other cases, maybe if there's something I want you to use, I might say, do this using these couple of functions or something like that, or assume you have a function named this and it does this other thing. So I might give you some code that does something. I won't ask anything on the plus, plus, minus, minus. We talked about that quite a bit. And if you never use that in your whole career, that's okay. But if you do, make sure you understand how it works when the plus plus comes before, the plus plus comes after. I would say it's not worth a question to ask about that. Here's the creating algorithm stuff. So make sure that you can sit there and write out. In fact, I might even give you a question that looks like a programming question, but instead of asking you to write the C++ code for it, I might ask you to, in English, write the individual things you would need to do to accomplish this. Give me the algorithm for the solution, with the expectation that once you had that, you would be able to convert it into code, but maybe I wouldn't ask you to make the code version of it for the test. Be able to write functions. Understand the syntax for a function. You need the return type for the function, which can be any of our types. Or if it doesn't return a value, it should be void. Then the function name, and then there's the comma delimited inputs or parameters. Here's that thing about the return statement. The most important piece of the return statement that isn't usually what people think of at first is return, at the very least, immediately makes a function end. That's what return does. If you are inside a function that's supposed to return a value, you can use the return keyword to ultimately return that value. And what it does is it makes the function immediately end and then spits out that thing you said to return. But the special sauce of the return keyword is it kills the function immediately. Doesn't go any farther. No more lines of code get executed. But yeah, and that's something that might be somewhat common in a function that returns void, that doesn't actually return a value. So in that case, if you said return followed by a semicolon, your goal is, I'm done with this function. I'm not giving a value out of here, but I don't want to do any more logic in here. I hit an if statement that said I've checked everywhere or whatever, so I'm just going to return, making the function die and move on instead of going through the loop another time or something. Yeah.
So what's like, I don't know, because it's just, it gets a point of functions and keep
Mm-hmm. Well, not necessarily. I mean, let's say that you have a function that takes in a string, and maybe the function's name is called, I don't know, doesn't have spaces or something like that, where it returns a Boolean and you want to pass a string to it, and the string returns, well, let's see, you don't want it to, you want it to return nothingness, but use return. the example I was just using would work, but that still returns a value. Really, I'm thinking about a problem where you're going through and you're checking. Let's say you're checking every element of a string as you're going through this loop, and you hit some element of the string that disqualifies the rest of the string. Like, I don't need to check the next 3 characters because something here has triggered my if statement to say, I know that I'm wasting my time looking any further, in my string for whatever reason, just using that as an example. So rather than letting my loop run a natural death, go through those last 3 times that maybe I've decided through my if statement is a waste of time. Maybe I know I'm not going to find my answer or something like that. Then you might just return and say, okay, I'm done. That'll get you out of the for loop, get you out of the whole function, so you don't do any lines of code after it. So realistically, it's not like that would be a super common thing you would see. It could also be error checking. So like maybe you have like a function that does authentication, tries to, even though we haven't talked to servers and stuff in here, but it takes in a username and password and checks to see if they're authenticated. Well, you might ask, if username has a length of 0, just return. You didn't give me a username. I don't need to check. I don't need to send nothingness up to Amazon or something to see if this person's authenticated. Then you might just say, okay, try again. Maybe you print out to the screen, no username given, and then just say return semicolon. And if they want to put something in again, it would be in a loop someplace else, wherever it called it. It wouldn't, I might say on the exam that you can assume there exists a function called index of. So I would say make sure that you know what this index of function did or something similar to it. Remember, index of effectively works, and this is a function we wrote. It's a function that exists in Java, in the character or the string class in Java. And there's probably an equivalent in C++. Maybe it's called find or something like that. But effectively, we have a function that takes in a string and a character we're interested in, and it returns for me the location in that string where that character was first found, or a -1 if it didn't find it. So like a Z is not found inside of this string. So it's just going to return a -1 to me. That's a function that could be helpful for solving some problems. You saw when we did our conversion code for converting between bases, we used index of on that map string to convert an A to a 10. It's fine. Does the same thing. And then give it a char. Yeah, so I would say this is fair game if you want to incorporate our index of function into an answer on the exam without writing it. You can just assume it does exist because that's kind of a tool we might use. I suppose it would also be fair game for me to ask a question that has you write index of. Write a function called index of that takes a string and a character, and it returns the location in that string where that character is first found, or a -1 if it's never found. That would be a pretty good example of like the complexity of a programming question on the exam. Okay, so I think that brings us up to date. All right, so I think that kind of covers what I'll focus on the exam. So we'll have it during class on Tuesday. I may physically come sit in this room. I don't know if I will or not. I might just be in my office, but it'll be on Blackboard. It'll open at the beginning of class. It'll be due by the end of class. Remember, Blackboard well, maybe you haven't had it yet since most of you are freshmen. Blackboard has like anti-cheating stuff built into it. So like, don't do Google searches, because I get a report that says you did Google searches during your during your exam. I want to see what's inside your head. Keep in mind that you can get a 0 on the midterm and still get an A in the class. So this is a test, not just for me, but it's to let you know how you're progressing with this stuff. Okay. So try not to put too much pressure on yourself for it, but prepare for it and go back and make sure you understand the stuff we've done in the homework and things like that. But the exam should be an individual effort. You know, don't sit with a group of three buddies and collaborate on the questions. I mean, you might be able to trick me. Who knows? I'm not going to spend my entire life looking for cheaters, but you're only hurting yourself. Because at some point you'll come out maybe with a degree and you haven't learned anything, and then you'll get fired over and over again. So, not my problem. All right. I don't do it specifically. Blackboard does something. I don't think it actually locks your browser. I think it gives a report of like searches. It captures keystrokes or something like that if Blackboard's open. I don't know exactly all the things it's doing behind the scenes, but I get like an anti-cheat report for each exam that, you know, might give a percentage of suspicious activity, you know, and if anything like less than 15 means, you know, maybe you checked your email or something like that while you were doing it. That's not a big deal, but you start getting like 70 and 80% returns on that, you were probably doing something funny. Certainly use a calculator on the exam. And, you know, so even the browser lockdown thing is kind of stupid because, I mean, you can just use the browser on your smartphone. So just don't. is what I'm saying. You're only hurting yourself, but you can use your calculator to do the conversions. But show me that you know how to do them. Show me the work, so that if you do make a mistake, I can give you probably significant partial credit because of the mistake you made. But if you just give me an answer and it's the wrong answer and I have nothing to go off of that you use the right pattern or something, then that'll just be yeah, but I mean, not like a ridiculous amount of typing. Yeah, I don't think there should be a major time constraint issue because you're having to type too much. I mean, the programming questions are going to be something in like the, you know, 5 or 6 lines of code length, you know, not a 3-page, you know, epic type thing. Same thing with the conversion questions. I mean, even on the conversion question, if you wanted to, you could do it by hand, take a picture of it, and upload that as your answer or something like that. Well, however you think is the best way to show me your answer is fine. Yeah. All right. Other questions?
So the one couple we had on the homework this morning and did his second attempt this morning, like a few minutes earlier, say from now. Would that be counted or would that not be? Like,
Well, you already submitted your homework and you just made a little adjustment.
Yeah.
It's fine. Did you learn something when you did that?
yeah.
Perfect. Mission accomplished. So, all right. So let's go and look at our homework assignment. We are updating our ROT 13. Okay. So in our ROT 13 right now, we have some, if you just remember here, ROT 13 can be used going both directions, right? It's the encoder and the decoder, encryptor and the decryptor for our string. So we're going to be building up a new string. So again, this is kind of the thought process through this. We're going to remember something. We're going to remember our answer. And it's going to start off as nothing because we're going to be concatenating onto it as we go through. We're going to have our entire alphabet here that we can use for counting 13 spaces forward. And then so what we do is we go through our source string. So this is our kind of canned for loop for going through every element of a string. Each time through, we ask the question, well, if it's a space, I think this came up last class, we'll say, what do we do with spaces? We just decided for spaces, we'll just leave it alone. If I see a space, I'll keep the space. Go ahead.
Is there any advantage of using double quotations after the string answer instead of just putting the semicolon right behind answer?
Well, yeah, because if you put the semicolon right behind answer like that, now we have a string that's been defined that doesn't actually have a value. Now, C++ might make the default value the empty string. So it might actually still work. But I would say this is bad programming practice, because what you did is you created a variable here of type answer, but it does not have a value. You created a spot to remember something, but you haven't been the one who put the value in there. So if you want it to start off as the empty string, put the empty string in there, because that's your base that you'll be building off of. Same thing when you're defining integers. If you want it to start off at 0, set it to 0, even though an int does default to a 0. More modern languages will at the very least give you warnings. Some of them will give you errors saying that variable XYZ may not have been initialized, something like that. And an error like that kind of lets you know that, oh, I probably created a variable and didn't put a value in it before I tried to use it. All right, so this if statement here just says, if I see a space, just keep it. Don't try to convert it into anything else. Spaces are just, we leave them alone. Otherwise, we're going to do our mapping thing. So we get our pause. So pause is going to be wherever the current location is of the character we're currently looking at in our string map. So this will tell us which letter of the alphabet we're looking at and where it lives inside of our alphabet 0 to bucket 25. All right. And then rot 13 says we add 13 to it. So we'll add 13 to it. Now, we could be in a situation where the number we are sitting at now is actually greater than 25, which is a problem since the last legal position in our alphabet is 25. So if I try to go and start talking about map at bucket 31, for example, C++ is not going to be very happy. Technically, this is a something called an array behind the scenes. So it's possible C++ would just give us a warning. But I would say a common use thing for this would maybe be a segmentation. It's called a segmentation dump using a memory error in C++. But we can at least all understand that, you know, if I have something that has 26 legal positions in it, 0 to 25, and I ask for the value at bucket 31, which doesn't exist, that's a problem, whether it screams at you or not, right? So if I'm at 31, what that actually meant is I had to go 6 more spots up here on this side. So I had to loop back around on the alphabet. And that's what we do here in our question. We say if pause is greater than 25, then we figure out, well, how far over did I walk? In my example right there, we walked six paces too far. And then just set pause equal to that difference. So that means when I wrapped around, I'd be at bucket 6. So the homework for today was, how do we effectively avoid having to ask that question? What do we have to change in this line of code to avoid asking this question? Go ahead. Yep, this guy's gone. That guy? Or you could have even just done it up here. You could have done that guy.
Always a more effective.
Yeah, just, I mean, you just do the math up there. But effectively what this guy is doing, use my example of 31, you know, as just to kind of show the math. So if I have 31 divided by 26 is what? How many times does 26 go into 31? 1 time. With what remainder? Remainder of 6. That's how we got the wraparound to the 6. Okay. If I was at 24, let's say, which we know wouldn't have to wrap around, right? How many? So 24 divided by 26 is what? How many times does 26 go into 0 times? With remainder what? 24. Okay, so this will always work. It allows us to wrap around to a 0 on a collection. So modulus is a pretty powerful tool for this kind of thing. Go ahead.
I just put the modulus 26 inside the map square bracket. Pause. I just put pause.
What do you mean you put it inside where?
Answer equals answer plus map pause. Modulus.
Oh, that's fine. I mean, you're doing the same math. Yeah. So he said he put it in here. He did that. Yeah, we're doing the same math, whether you do it here, here, or here. We're ultimately taking pause and we're dividing it by 26 and taking a peek at the remainder, right? We just want to make sure that when we actually go and map it, we have the remainder dealy flippy instead of our number that might be off the end. So at some point in time, before we actually resolve map it, bucket, pause, we need to have that remainder based answer. All right, questions about this? All right, so I'll go ahead and save this. So hopefully that wasn't too challenging for the homework assignment, but it was kind of more one of those puzzle type things where you had to kind of think about, well, do I have anything that behaves like this? And really where you probably should have started on this question is something along the lines of like the example I gave. What if I add to my number and I'm at 31? Well, clearly that's a bad place. It needs to get to a 6. What can I do if I have a 31 to get a 6? What tools do I have laying around here that might allow me to do a little mathy trick thing? Go ahead. We're dealing with that right here. Oh, you're saying, how do I remove the spaces? Oh, because right now we're keeping the spaces. So you want to actually get rid of the space. Well, so if you're gonna do, I would probably write it's a couple different ways you can do it. So your ultimate answer will be the thing without spaces. Okay, I mean, you'd have a lot of trouble getting it back to its original form then. Because if you remove spaces, then you no longer know where the words break up. Yeah, maybe I gave you let's just write the thing I referenced on the midterm rather than maybe break this. I mean, we could do it here, but you kind of have like a broken encryption thing, right? You can still convert it back and probably a human being could look at it and see it still says hello world. It just now they're all run together, but you kind of lose some meaning to it. But I had mentioned maybe on the exam, we have like a function called remove spaces. That takes a string as a parameter. Now, typically, see, strings, we can't directly change. A lot of languages do have a kind of a buffered string or something like that that does allow us to modify things within a string. But if we treat strings like we've learned them in here as these entities that hold values but can't be changed, when I say remove spaces, what I'm really, the way I would translate that in my head is I would say, let's keep everything that's not a space. So I would start with an answer here. So I want to build up my answer, and then I'd have a loop that goes through every element of my string. And I would say, if asset bucket I is not equal to a space, tacking on in the end return answer. So now I have a empty string that I'm building on top of. I'm going to go through every character in S. I'm going to say, is the current character I'm looking at something other than a space? If it is, tack it onto my answer. If it is a space, I just don't do anything with it. I just skip right past it, move on with life. That makes sense? Go ahead. This would be in the spirit of something that might be on the exam. I think it's unlikely I'll ask you this exact question now, but I might ask a question like remove vowels or count vowels in a string or count spaces or count punctuation, where punctuation is commas, periods, and question marks. something along those lines. But this would be a reasonable example of kind of the length of a question for one of the programming questions. Probably no longer than this. Some of them would be shorter than this, but this would be as complex as I might get in a programming question on this exam. But well, we just wrote it. Yeah, we made it. We invented this function. Because we said, hey, we want to have a tool that I can toss a string at and it'll hand me that string back or a similar string back that is the original, but with all the spaces taken out. That's what this guy does. All right, makes some sense? All right, if you want. No, I'll just give you, how about I just give you everything? Well, actually, why don't you remind me at the end? Let's do a little something. Let's add some stuff to this and go from there. So what we're going to do next is we're going to start our trajectory towards objects, which will start the Tuesday following next week, since we do have fall break at the end of next week. So we won't meet on Thursday, and we'll digitally meet on Tuesday for the exam. If you don't want to get on the Zoom, you don't have to. Just make sure you have the exam completed by the end of class, and the exam will open at the beginning of class. So you're still going to be active during class. All right. So we're going to say C++ random number. So we have a function called rand in here, and another function called srand. Let's use this one. All right, so we do have a function called rand that gives us a random number in C++. I'm going to show you, there's actually some more modern random number generators, but I want to show you kind of a truth that exists in some random number generators, because actually good sources that emulate or simulate randomness is actually very difficult. You know, like pick a number between 1 and 10. We all might pick a number, but having a very even distribution of numbers between 1 and 10 might actually not that. I'm guessing maybe some of you might be more prone to pick smaller numbers. You know, maybe 80% of the time you pick a number between 1 and 5. So that's not truly random, right? Because we're biased or something like that, or something in our psychology that is that a thing? Yeah, 7 comes up more than any other if it's a human being picking it.
See, if I was bullied by the number 3,
I had 3
Yeah.
bullies.
Yeah. So you get the point, right? True randomness is difficult, because even as a human being, if we're trying to come up with a random number, we don't believe that we're going to have that even of a distribution. And what I want to show you here, I'm pretty sure this rand function works this way, about 98% certain. Here, let me prototype this guy so he doesn't scream at us. Actually, he would be fine because I don't actually call it right now, but I'll still throw it up there. All right, so what I'm going to do here is I'm going to say, let's just do a for loop. For int I is equal to 0, I is less than 10, I plus plus. All right, so we're going to do something 10 times. And what we're going to do is we're going to see out rand. So that's all programs begin and end with main, right? So what does main say to do? Main says that we're going to go ahead and create a loop that goes through 10 times. That's what that loop does. Goes through 10 times. What do we do each time? We're going to output to the screen the result of calling the rand function that I just introduced. All right. So what that guy does is it gives us random numbers in the range of signed, actually, is it unsigned? Might be unsigned integers here. I don't see any negative numbers, and is that just bad luck? Okay. But now I want you to notice something here. I just ran it again. Just stare at the top number first. Everybody's got that top number mostly memorized. Okay. I can run this over and over and over again. It's going to keep giving me the same distribution of numbers. Okay. And just as a quick I just want to make sure that it does only positive numbers before I advertise that. I'll do it 100,000 times. If I don't get one random number, one negative number in 100,000 rolls, probably no negative numbers. Yeah, gives you positive numbers. So it's probably going to give us numbers in the range of 0 to 4.2 billion would be my guess. The range of all unsigned integers, because now we get to use the entire 32 bits. Not all that important for us, just kind of knowledge for us to remember that a random, the rand function gives me values between 0 and some giant number. Okay. What if I want a value between 0 and 10? What can I do? Mod it by what? Modding it by 10 will give me a value between 0 and 9, right? Okay. So mod it by 11. Mod it by 11 will give me 0 to 10. If I want 1 to 10, I can mod it by 10 and add 1. All right, so I can do something like this. Mod 11. We'll go ahead and print out val here. And we'll just do this 10 times. And now we'll see a whole bunch of numbers between 0 and 10. Okay, but again, yeah, we got the same thing of numbers, right? So in most programming languages, whether it's happening automatically behind the scene, which it's not here, we have the ability to seed a random number generator. And the common way of doing that typically is through the time library. And I'm sure they give that example here. Yeah, so they include time.h, which then allows us to call this function called srand. We're seeding the random number generator. So if I just throw this into my code real quick in our last minute, I'll call that guy. I need to include time.h. So there's a 9-4. There's our first two. 110. Now we have a more evenly distributed random number generator, but I'm sure it could probably be proven it's not perfectly random. All right. So I'll put this up just so you have this as a basis. The stuff we just talked about here in the last few minutes, the random number stuff, will not be on the exam. Okay. But we're going to use it. We're going to start writing a dice roller next class, or next actual class. And then we're going to convert it to an object where we can create a D6, a D4, a D20, that kind of stuff. And then we're going to use it to make a Dungeons and Dragons kind of, death match. Have two player objects fight each other. We'll make sure there's plenty of blood and all that jazz. Okay. All right. Well, I'll put this code up on Slack, and I will. I'll see you after break for many of you. But remember, class time next Tuesday will be the exam, and it will be on Blackboard. It doesn't matter where you take it, but you're taking it during class time. Got it? All right. What's up?
So if you were to remove all vowels in a word, would you make a string with the vowels included?